Okay, some more problems from section 4.5, and this is 29. So I wrote it over on the right, and I kind of hadn't finished. I had some whiteout because I wrote down the wrong problem, and I had finished it, so that's why I had to make a shorter video on the last one. So this is what we've got, and again, we're going to have some kind of a period change here because we've got something in front of the x, and we're not supposed to have anything in front of the x to analyze the shift. So I'm going to have to factor out whatever's in front of the x, and that'll be easy to do in this case. So this is going to be y equals negative sine, and I'll take the 2 pi out, and what's left is x plus 2. So there we go. So it looks like now if I take the 2 pi, if I define my period, remember, is 2 pi over b, so that's 2 pi over 2 pi, which is just 1, so my period is going to be 1 radian. And I've got a shift. Now this is also in radians, so that's nice. So I've got a shift, and that's going to be the left to 2 radians. So I drew my scale, and a lot of the thing is to make sure you can draw your scale right. So if I look at this, this is my axes, and this is my radians, and I put in radians, and this is negative 1 radian, which is about 57 degrees, a negative 2 radians, which is 114 degrees, about, approximately. And this is a positive 1 radian, again at 57 degrees. And I've got a period of 2, so I'm going to come down here. I'm going to have some problems here. I'll be kind of close to this. I've got a period of 2, and it's negative. So we're going to go negative, then positive, rather positive than negative in our 1s, which would be 2s in this case. And these are a period is going to be just 1 radian. So it's just going to be from here to here. So now I pretty much have to divide this into 4 equal subdivisions. Wish I would have done that with my ruler. So I'll have to kind of eyeball that. I think I got it pretty close, okay? So there's my 1 radian, so this is minus 2. And remember, if we just take 1, if we want the length of each subdivision, we could take the period, which is 1, and I could just take 1 divided by 4, and 1/4 is the length of each of my subdivisions. So I would take this unit, and I would divide it into fourths. So this would be minus 2, minus 1 3/4, minus 1 1/2, minus 1 1/4, minus 1. So I could call this negative 3/2, 1 1/2, if I wanted to. Okay? All right, so those are my subdivisions. This is going to be 1 period, the length of 1. So I'm just going to go from there to there, and I'll start at 0. That's no problem. And then usually I go up 1, but because I've got a 2 here, a negative 2, I'm going to go down 2. So I'll put it right here. I go back to 0, and instead of going down 1, I go negative 1 is, or negative 2 times negative 1 is positive 2, so I'll go up 2. And then back to 0. Now the nice thing is the zeros are always the same. And again, if this was just a positive 2, I'd be going up 2, 0, down 2, 0. But here I'm going to, because it's negative, I'm going down 2, 0, up 2, 0. And there you go. So those are your 5 points. We can graph it now. Let me curve it around so I don't make lose the symmetry of the curve for the niceness of the curve like I did on the first problem. There we go. Now again, it's the way you do your scale, so this could look very much like the first curve, but if it was in scale it wouldn't be, but it's hard to do a regular scale and stuff. So there you go, something like that. Okay, so it's shifted over 2 radians to the left. That's a 2 radian shift to the left. The period, because of this, is 1 radian. So there we go. And I've got an amplitude of 2, but it's negative, so it's going to go down and up rather than up and down. Okay? All right, let's take a look at 43, and 43 is a cosine. And that's not too bad. It's just a shift. So we just have a pi to the 2 to the right. So here I'm going to start at pi over 2. And the period for the cosine is also 2 pi, so normally it would go from 0 to 2 pi, so now it's just going to go to pi over 2 to this, which would be over 2. This would be 4 pi over 2. This would be 5 pi over 2, and this is how I go. And there's no period change, so it's just 1. So I put my 1 up here a little higher so I can see the curve better. So I'm going to start here, but I don't start on the cosine, I don't start at 0, I start on 1. So it goes 1, then 0, then down 1, then 0, then back to 1. Okay, and again, my period is going to be 2 pi, so each of my subdivisions will be, my period is 2 pi, so each of my subdivisions, that would be 2 pi over, I can write that over here. Period is 2 pi, so I can just take 2 pi over 4, which gives me pi over 2, and that's the length of each of my subdivisions. So pi over 2 to pi, 3 pi over 2, 4 pi over 2, 5 pi over 2. Okay? And then we can just graph it. Now remember, the cosine looks like this. It starts at comes down here. And then it ends up at 1. So something like that, okay? And if I use the pencil, I could refine it a little bit better, but hopefully you get the idea. All right? Okay, then 45. Let's think about 45 now. We've got a period of 3, so we're going to go up 3, down 3. And then we've got some kind of shift here, but I got a 2 in front, so I'm going to have to fix that. So I got to say this is the same thing. I'll write it over here as 3 cosine, and I'm going to get out of 2, so I'm going to write this as 2x minus 2 pi over 2. I'll multiply the top and the bottom by 2. That way I can take the 2 out, so I'll get, I'm going to have some shift over here too, so maybe I'll write it over here so I don't have room. So I'm going to have 3 cosine, and if I take the 2 out, 2 times x minus pi over 2. So that's what I've got. 3 cosine 2, I took the 2 out, and then I've got x minus pi over 2, because I doctored this up so I'd have a 2 on the top, so that's going to be my shift. So I'm going to have a shift of pi over 2 to the right, okay? So I'm starting pi over 2. This will be my starting point, pi over 2. Kind of like the 43, except I had to work at it a little bit more. And again, I'm going to go 1, 2, 3. These will be my 4 subintervals, so this will be 5 pi over 2, so I have the same 1, 2, 3, 4 subintervals, except my period is just positive. I'm sorry, my amplitude is positive 3, so I'm starting at 3. So starting at 1, we start at 3. It's positive, so that's right here. Okay, and this is a 0. Then I go down to negative 3 here, back to 0, oops, back up to 3. And there you go. So the period is, oh wait just a second, my period is what? What's my period? My period, I forgot to check out my period. Excuse me, pardon on me. What's my period? My period is, sorry, period equals, I forgot to check that out, 2 pi over 2 over b. B is 2 over 2, so my period is pi. Oh, okay. So pi over 4 is one increment, or pi over 4 is one of the subintervals. So I'm going to go here. So I'll divide these up, and this will be pi over 2 to 3 pi over 2. Sorry about that. So that's actually where I'm going. So now I'm going to go here. This would be the 0. This would be the negative 3. All right. This would be back to 0. And that'll be back to 3. So let's get our trusty white out and get rid of some of this other stuff. So we'll white this out here. I'm not going to use that. Obviously not going to use that. And not going to use that. So there we go. Pardon me. Sorry about that. Okay. So again, take a look at it. You have to analyze the equation, and lots of times they'll just ask you, we'll give you an equation like this, And one good possible test question is to make sure you understand this is, you know, if you look at this, what's the amplitude? Well, the amplitude is 3. What's the period? Well, I have to take this out, 2, so 2 pi over 2 is pi, so the period is pi. Okay? And what's the shift? After I take this out, the shift is to the right pi over 2. So here's my shift to the right pi over 2. Here's my amplitude, and here's my period, means I'm going to go from there to there. Okay, so fix that up, and here we go. So I'm going to be real steep. Come down here. Loop up here. And come down here like that. So that's the way it's going to look. Okay, there you go. All right. So you can see the difference. The one up at the top, the period is 2 pi, and here the period is 1 pi. Here the amplitude is 1, here the amplitude is 3. I changed the scale a little bit, so oftentimes that'll bias it. It'd be great if, you know, we could use exactly the same scale for all the problems and you could appreciate them. Okay, so hope that helps. There you can see all 3 of them right there.